Good morning, Julian. This is Shivalji speaking. In the previous video, we had a discussion, a few concepts of cube and cube roots, and today we are going to deal with one question which you have raised. You had a problem in this particular question. Some queries I received from exercise 7.1, question number 4. The question was. Parikshit makes a cuboid of plasticines of sides 5 centimeter, 2 centimeter, and 5 centimeter. How many such cuboids will he need to form a cube? Children, as I have explained about square and square roots, in that in all those videos of square and square roots, I had explained how to find square and square root of a number by using prime factorizations methods and all that. So children, one thing that we have to understand, that this particular chapter, cube and cube roots and square and square roots, is pretty similar. The concepts of finding the cube roots and all, it's quite similar. But this particular question number 4, which we can find slightly different, which we really need to understand. And many of you had faced problem to understand this particular question. So children, here is the process. The very first things that you have to understand, what is the basic difference between cuboid and cubes. Children, cuboids is a rectangular box in which the measures of all three sides, all three dimensions, length, breadth and height is different. They're different from each other. I mean, they are not all same. They might be, maybe lengths and breadths are same, height is different. Maybe lengths and heights are same, breadth is different. Maybe breadth and height is same, but length is different. Possible. Thing is that they are not similar. I mean to say, length, breadths and heights, they are not similar to each other. They're not same. When we talk about cube, a cube is a squared box in which all three dimensions. When we talk about square, the very first things that we understand, that square is a two-dimensional figure in which two sides are measuring same. Lengths and breadths are same. So when we're talking about a cube is a squared box in which length, breadths and heights are same. All three dimensions are same. They are same. If the length is 5 centimeter, breadth must be 5 centimeter, height must be 5 centimeter. So this was a little bit concept about cuboid and cube. So in this particular question, it is told that Parikshit, a boy, makes a cuboid of plasticines. Plasticine something, a chemical substance for making, we use for making various objects. 5 centimeter, 2 centimeter and 5 centimeter. These are the measures of the dimensions of cuboid. 5 centimeter, 2 centimeter and 5 centimeter. Question is, how many such cuboids will he need to form a cube? Now this 5 centimeter, 2 centimeter and 5 centimeter measuring cuboids, how many cuboids will he need? If you suppose he wants to build a cube, so of course he will be requiring some cuboids. I mean, he wants to build a cube using cuboid only. Imagine, boys, let me explain it in other way. Suppose you have some matchboxes. Matchboxes are shape of cuboid only, and you want to make a cube using matchboxes. Now question arises that how many matchboxes you can use in order to make a cube. You want to give a you want to make a block of cube using all cuboids. How many cuboids or how many matchboxes will be needed? That is what this question is all about. The cuboid you are having measuring 5 centimeter, 2 centimeter and 5 centimeter. All the cuboids are of same measures, same size, same shape, and you want to build a cube of using that. cube of using those cuboids. How many cuboids will you need? Children, the very first thing that we need to understand, what is the volume of such cuboids? Let us find the volume of cuboids. There is a formula, children. Volume of cuboid is equal to length into breadth into height. Such a formula or such pattern of questions you will learn in higher classes. In higher classes, these things are explained nicely. So the length, breadth, and height. If you find the product of all these three dimensions, you will get the volume of cuboid. So length is 5 centimeter, breadth is 5 centimeter, and height is 2 centimeter. 5 is 25 into 2, it's 50 centimeter cube. Always remember, children, whenever we write the unit of volume, it comes cube of the units cube, because you are multiplying three centimeters: 5 centimeter, 2 centimeter, 5 centimeter. So 5 to 25, 25 into 2 is 50, and centimeter into centimeter and centimeter results centimeter cube. So this is the volume of each cuboid. Okay. Now, children, the thing is that we have to find prime factorization of this number. Prime factorization of this number, because, sir, why we should find prime factorization of 50? Because 50 is not a perfect cube number. The word perfect cube, word itself gives the concept of this question. 50 is not a perfect cube number. So some numbers are to be multiplied. Some numbers are to be multiplied with 50 in order to make 50 as a perfect cube. I'm repeating my word once again. Children, 50 is not a perfect cube number. 50 is not a perfect cube number. You have to multiply some numbers with 50 in order to make this particular number a perfect cube number. So let us go and check which number or how many numbers are to be multiplied in order to make 50 as a perfect cube number. Let's go and check it out. I'll perform prime factorization of 50. 2, 25, 5 and 5. So I can see 50 is equal to 2 into 5 into 5. Children, from here, this pattern we can understand there are some shortage of some numbers in order to make this particular number a perfect cube number. What are those numbers having shortage over here? First of all, I can see here is a single 2, means more 2 will be required. So children, I am multiplying over here and I am circling it out. I need one more 2, I am circling it out. Here is, I have got a pair of 5, I need one more 5, I am circling it out. So children, how much I am multiplying? 2 2s are 4, 4 5s is 20. 2 2s are 4, 4 5s are 20. Means if I multiply 20 with 50, I'm supposed to get a perfect cube number. That is 1000, because 20 into 50 is 1000. Children, I hope you are able to understand my word. 2 2s are 4, 4 5s are 20. If I multiply 20 with 50, so this particular number will turn into this particular number 50 will turn it into a perfect cube number. It will be 1000, and we know that 1000 is a cube of 10. So 20 is required in order to make 50 a perfect cube number. 20 is required. So children, that is what my answer is all about. 20 cubes. 20 is required to make 50 a perfect cube number. 20 is required to make 50 as a perfect cube number. So 20 is the answer. 20 is the answer 20 such cuboids will be required. 20 numbers means 20 number of cuboids will be required to make a perfect cube number. Children, this was all about question number 4. I took much time to explain this because I want you to understand this particular question just from the root of the process. Because if you understand this particular question, you would never have any problem in future to understand any concept of cube and cube roots. Children, here the more questions which I have written over here, that is of exercise 7.2. Find the cube root of each of them by using prime factorization. So I wrote some numbers. Those are 64, 10648, 10592, 91125. Children, these numbers we have to find cube root of these numbers by using prime factorization. So which I want from you all. Those who have already done, they're okay, absolutely fine. Those who haven't, it's been requested to them to find these numbers, to find cube root of these numbers by using prime factorization process. Absolutely simple, just which you have done in square roots chapter. By using that process, we have to find the cube root of these numbers. So it's been expected from you all to try this out your own and submit to me as soon as possible, as soon as you are over with this questions. And I'll be expecting this sum of Parikshit should be submitted, and try this out your own. Understand, watch this video very nicely again and again if you face problem to understand, and drop your queries if you're having any problem. Till then, thank you children. Thank you so much.